Clear. Now, the next topic, or the next type of number, is something that's useful. Again, you'll see it on your test, you'll see it in your pre-algebra course, but I'm not going to sit here and lie to you. It's not something that you're going to use in every section coming up here in the rest of the algebra sections. But it's something that you probably have heard about, and it's called a prime number. And the only reason that books really even talk about prime numbers is because they're kind of special numbers. A prime number is a whole number other than 0. The little line through it means 0, so you don't confuse it with the letter O. 0 and 1. Other than the number 0 and 1, that is divisible by only the number 1 and itself. And every time you write the definition of a prime number, most people, their eyes cross and they just don't quite get it because it's kind of a complicating sounding thing. It's whole numbers other than 0 and 1 that is divisible by only 1 and itself. It just doesn't seem to make a lot of sense when you write it down, but you'll see why it's written this way. Let me give you an example of some prime numbers. The number 2 is a prime number. The reason it's prime is because the number 2 is only divisible by the number 1. When I say it's only divisible, I mean only divisible with no remainder. So you can only divide this number by the number 1, because 2 divided by 1 is going to give you 2, and you can divide it by the number 2, which is itself. 2 divided by 2 is 1. You can't divide it by anything else. 2 divided by 3 gives you a decimal, 2 divided by 10 gives you a decimal, 2 divided by 4 gives you something else. You can only divide it by the number 1 and the number 2, which is itself. That makes it a prime number. The number 3. You can only divide this number by, actually let me go across here. The number 3. You can only divide it by the number 1 and the number 3. You can't divide this number by 2 because that would be 3/2. That's a decimal. You can't divide it by the number 5 because if you do, you're going to get a decimal answer. When we say it's divisible by, we mean divisible where you don't have any decimal left over. So 3 can only be divided by 1 and itself. 5 can only be divided by 5 and 1. 7 can only be divided by 7 and 1. 11 can only be divided by 11 and 1. 13 can only be divided by 13 and 1. 17 can only be divided by 17 and 1. 19 can only be divided by 19 and 1. 23 can only be divided by 23 and 1. And you could go on, and you can get a computer to calculate all the prime numbers out as far as you want to go, and that's fine. People do that. But just know that it's sort of an infinite series of numbers that have these special properties. Now let's look at something that's not prime, just to kind of give you an example. 8, the number 8 is not prime. And the reason it's not prime is because, I'll just put because, B-E-C, you can divide it by 2 and you can divide it by 4. 8 divided by 2 gives you 4, and 8 divided by 4 gives you 2. So those are 2 additional things besides the number 1 and the number 8 you can divide into there. And so it's not prime. The number 10 is not prime because you can divide the number 10 by 2, and you can also divide it by the number 5 evenly. One more example. The number 12 is not prime because you can divide it by a whole lot of numbers. You can divide it by 2, you can divide it by 3, you can divide it by 4, and you can divide it by 6. So you see, the higher up you go in the numbers, you're usually going to be able to divide by lots of different numbers that will divide evenly. But every number in this list, the only numbers you can divide into there is the number 1 and itself, which itself is the number itself. Okay. Now also notice that prime numbers exclude 0 and 1 from being prime by definition. That's just the definition of the prime number. So that's what it is, ladies and gentlemen. Those are the types of numbers that we're going to learn in this section. Let me draw a quick graphic because I think it's going to make things a little bit clearer. And then after that, we will work, I guess, a couple of practice problems to kind of show us where we're going. So first, we have what we call the real numbers, right? Which is basically everything, everything except for the so-called imaginary numbers, which you typically don't learn in algebra, but just keep in the back of your mind that there's something called an imaginary number. You've never used it up until now. It's something that's kind of a little more of an advanced concept. But everything else left over is what we call real. That's why they're real. We can touch them. We can use them to count marbles, things like that. And a real number is basically everything. So that's the top level of the hierarchy. And coming out of the real numbers, you can kind of split this into the rational numbers. Right, the rational numbers, and of course, the irrational numbers. Right? Now, just to refresh your memory, something like an irrational number would be like the number, pi. 3.14159, dot, 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 dot. You cannot write this as a fraction. All of the rational numbers can be written as fraction. All of the irrational numbers are just these random decimals that go on and on forever, and you can't actually write them as a fraction. Let's change colors. Now, this path kind of ends right there. Now, the rational numbers can be broken down further. So the rational numbers, you have what we call the fractions, right? So that would be, just like you would think, 1/2, 2/3, -1/4, dot, dot, dot. Just any kind of fraction that you would think of is rational because, remember, rational numbers can be written as a fraction. So, of course, the fractions are rational, right? And then you have decimals. Now, when I say decimals, these are decimals that have some kind of pattern to them. Even if they go off to infinity, they have some kind of pattern, or they just terminate. So something like 0.25, 0.333, bar on top. So 0.25 can be written as 1/4. 0.3333333 off to infinity, that can be written as 1/3. Any of these decimals that have any kind of infinite pattern or just a decimal that stops can be written as a fraction, so it's rational. And you also have what we call the integers. And those are things like, -2, -1, 0, 1, 2, dot, 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 in both directions, right? So all the negative numbers there, all the positive numbers there that don't have any decimals, and also the number 0. Those are integers, right? And any of these integers can be written as a fraction also because the number 2 can be written as 2/1. The number -2 can be written as -2/1. So you see that the world really consists of these real numbers that are broken into two camps. The rational numbers can all be written as fractions, and they would consist of, the fractions, because they're already fractions, the decimals that can be written as fractions, and the integers that can all be written as fractions too. So pretty much every number you've ever used is over here somewhere, right? The only numbers that are a little weird are these things called irrational numbers, and there's not too many examples of them that you really are already familiar with, but just know that they're out there. Something like pi, you could probably go and calculate different irrational numbers without a problem. And those are numbers that just go on and on forever with no real pattern to them, and you cannot write them as a fraction. That's really the definition.